Okay, so lesson 3.1 is where we learn about lines and angles. And you should already know what a line is. You should already know what an angle is. So how to name them, how to identify them. But we're going to review some key definitions and then add a new definition. So a definition we talked about before is parallel lines. And something I want you to understand about parallel lines, they have to be coplanar lines that do not intersect. So coplanar lines that don't intersect. So AE and BF, I'm going to use yellow. AE and BF are parallel because they don't intersect and they're part of the same plane. Okay, I'm going to use blue to describe skew lines. Skew lines are lines that are not coplanar and do not intersect. So basically, skew lines are lines that do not intersect, that and this is a simplified way, but they point in different directions, not opposite directions, just different directions. So an example of skew lines, I'm going to do CG, okay, CG and EF. Okay, that's an example of skew lines. They are not part of the same plane, and they do not intersect. So we just think about those as lines that are not part of the same plane that do not intersect. So lines that don't intersect that are pointing in different directions. And parallel planes is a pretty simple one to understand. Parallel planes are planes that do not intersect. There's no other definition for those. So a pair of parallel planes, I'll highlight them in red. DABC, kind of like the ceiling of this box here. The parallel plane to that would be HEFG, this bottom plane. So parallel planes are planes that do not intersect. So parallel and skew both mean don't intersect. Parallel lines are lines that do not intersect and go in the same direction. Same direction. Okay. So at the bottom here, or in example 1, we're going to apply these definitions, and we're going to use that diagram at the top to help us. But non-coplanar describes skew lines. Coplanar represents parallel lines. Both of these do not intersect. So this describes both parallel and skew lines. The term intersect does not describe either of those. From the diagram up top, that's where these lines are being compared. AE and CG are examples of, and I got to move this up a little bit, AE and CG are examples of parallel lines because they do not intersect, but it's understanding that they point in the same direction, okay? They point in the same direction. CB and AE must be skew because they do not intersect and they do not point in the same direction, meaning they are not part of the same plane. So two lines that point in different directions that don't intersect cannot be part of the same plane. So that's the big difference between parallel and skew. Planar versus, or coplanar versus non-coplanar. So in example 2, listing all the segments that are parallel to AD, it's all lines that don't intersect AD that run from left to right, or segments that run from left to right that don't intersect AD. So that would be BC would be an example, FG, and EH, and that's it. Those are the lines or the segments that do not intersect AD and run left to right. Now I'm looking at BF, and I'll highlight BF because this is a little tougher to pick out skew lines. Skew lines run in a different direction from BF, but do not intersect BF. So an example of a skew segment, AD and EH. They both run left to right. They both won't intersect BF. Another example of a skew line to BF would be CD and then HG because they both point in a different direction and do not intersect BF. The reason AE, DH, and CG are not skew is because they run in the same direction as BF. The reason CB and AB are not skew Because they actually intersect BF right here. So it's understanding skew means don't intersect, and they run in different directions. So this is the big idea for the rest of this kind of cluster of lessons, these terms. And you'll get a foldable on these terms eventually. But to talk about these different angle pairs, when you have two lines formed by a transversal, or angle pairs formed by a transversal. So you're going to get situations where you have a line, you have another line, and both of those lines are being intersected by the same line. That intersecting line is called a transversal. Okay? So when this situation happens, you have interior angles, you have exterior angles. Angles 1 and 2 and 7 and 8 are exterior angles. Angles 4 and 3 and 5 and 6 are interior angles. So alternate interior angles are angles that are not adjacent to each other, that are interior angles and lie on opposite sides of that transversal. So an example of alternate interior angles would be angle 3 and angle 5. Those would be alternate interior angles. They're not adjacent, they're interior, and they're on alternate sides or opposite sides of the transversal. Same side interior angles are interior angles, but they lie on the same side of the transversal. So an example of same side interior angles, angle 3 and angle 6. Those are same side interior angles. The one that's a little bit tougher to pick out sometimes is corresponding angles. Corresponding angles lie on the same side of a transversal and are in corresponding positions. So I'll give you a couple examples of corresponding angles. The angle corresponding to angle 1 is angle 5. They are both in the top left position on the same side of that transversal. Another example of corresponding angles would be angle 3 and angle 7. They're both in that bottom left position, or bottom right position on the same side of the transversal. So those are corresponding angles. And then alternate exterior angles are exterior angles that are on opposite sides of that transversal. So angle 2 and angle 8 would be an example of alternate exterior angles. So, for example 2, you're using this diagram at the top to draw a line to the to the correct theorem that this follows, okay? The correct property or correct angle pair. So angle 4 and angle 6, they're both on the interior, they're on opposite sides. Those are alternate interior angles. 3 and 6, I kind of showed you that one. 3 and 6 are same side interior, so that line goes straight across. 2 and 6 would be an example of corresponding angles. They're on the same side of the transversal. They're in that top right position. And then 2 and 8, like we covered, wrong way. 2 and 8 are alternate exterior angles. Alternate opposite sides of the transversal on the exterior of the lines. So, in example 3, 3 pairs of corresponding angles at the right might be a good chance for you to get a little bit of practice. If you want to pause the video, I'll stop talking for a few seconds to allow you to pause it, and then resume it when you're ready, and I'll flash my answer on the screen and then go to example 4. So I gave all 4 pairs because there are 4, but if you had any 3 of these pairs, you had 3 pairs of corresponding angles. 1 and 3, top left position. 2 and 4, top right position. 8 and 6, bottom left position. 7 and 5, bottom right position. So that means corresponding. And then example 4 is a pretty quick one. Angles 1 and 3. If you look at angles 1 and 3, look at where they are and think about what relationship they'd follow. Now, these are on the same side of the transversal. Okay, they're on the same side, and they're both in that, what we call that top left position. So these would be another example of corresponding angles. Okay, so this lesson is just about knowing the difference between parallel versus skew, and then building the definitions of these 4 theorems that we are going to use over the next 2 lessons, and these kind of pop up as we go through other lessons. So these are important theorems, not so much later on to name, but to know what relationships they have when the lines are parallel. So you should be ready to take on the practice right now.